Hi. Welcome to KTB TV. I swear this isn't my first stream, but I do have music in the background for the first time, so that's going to be interesting. Hi, I'm Kevin. This is zoomed in very close, so, hands. I am doing something completely different than what my channel normally does today. And I apologize for the band-aids, but I figured you'd rather see band-aids than my torn cuticles because I have terrible habits, and my hands have never had to be on camera before. So, yeah, what am I doing today? I am building a breadboard CPU. I have here module 1 of 4, slightly out of focus because my focus is currently fixed on the board behind it. I have purchased from Mr. Ben Eater of Khan Academy previously, and currently does digital electronics videos on YouTube. I have purchased from him the kits that he makes for making his gigantic breadboard CPU, because it's something that has always appealed to me, of trying to put together through just logic gates and pure gumption, putting together an entire computer, or at least the thinky bits of the computer. So I'm going to be very rambly in this, but this is what's going to be happening. This is much different than I normally do, so please give me a bit of your patience, and let's see what we can do about getting this unpacked. I know this is much more zoomed in than a normal unboxing video would be, but again, I don't really want to deal with a bunch of the problems that I am going to have to deal with my camera mounted in the most awkward possible position. So, let's see, what do we got? We've got a breadboard. We've got a bunch of the actual parts. We've got some wires to hook it all together. And you can see my cameras. And, oh, hey, you can see my webcam. And so kindly, because I have done some tiny little, this is like completely torn apart. This isn't even actually most of the circuits that were on that, but I've been doing some tiny little things with my little breadboard kit that I've had for ages, and I was not looking forward to using my torn apart USB cable that doesn't really stick into the breadboard itself very well. He supplies this nice power supply. Let's get that out of the way. Rustle. All right. So, just to go over what comes in this kit, there's a whole nice booklet that comes with it. Components included in this kit: one breadboard, check. Jumper wire kit, check. Power plug, check. Power plug adapter. So let's. I do want to go through all of this all at once, all at the beginning, because I'd rather make sure that I have it all now. So let's. Okay. So let's see. We've got a power plug adapter. Perfect. Power plug adapter. See below for how to use it. I believe that's over here. 3555 IC timers. I believe that. This is why I have this focused exactly here. 1, 2, 3. One hex inverter, quad AND gate, and OR gate. I'll decipher which of these are those. That's going to be interesting. Alright, I know this is actually zoomed in a little bit too much. Hold on, let me, okay, there we go. me turn autofocus back on, I guess, so that this is not just slightly out of focus for the rest of the video. Autofocus. What do you think? What do you think, autofocus? No, you're very confused, aren't you? You have no idea what to focus on. Can you focus on this? Not well. Okay. You focus on this. I mean, it can technically, but hold on a sec while I crank this focus in here. Hold on. Come on. There we go. Okay. Alright. That should be darn close enough to focus that it shouldn't make a difference. Alright, so momentary push button. Let's see, where are the push buttons? Uh-oh. Oh, they were in this kit. Okay, I was wondering why this had so many things in it. So we've got a push button in here. We've got 1 mega ohm potentiometer here. And we've got a slide switch. Yeah, that is very familiar to me. I haven't used a lot of these components. I've used the push buttons and the slide switches in my old CS courses. Obviously, we've got a pack full of resistors. Here we are. So we've got a bunch of resistors. Some yellow LEDs. Where are my LEDs? Some yellow LEDs. And some blue LEDs. Hey! Oh. Yeah, I got extra LEDs. Yellow LEDs, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I got 10. And that's 2 extra, so includes 5 extra. 5 blue LEDs, includes 3 extra, so there's our blue LEDs. Let's see, we've got our 100th of a microfarad capacitor and our 10th of a microfarad capacitors. And then we've got some 1 microfarad capacitors, and I do not see, where am I missing 5 10 microfarad capacitors? Oh, nope, they're just a different color. I was looking for blue and they are yellow. Let's just double check this. Yep, 25 volt, 10 microfarad. Perfect. They're a slightly different color. That's fine. This project provides a 5 volt. Powering your project. This power supply provides 5 volts and will power the entire computer. You can use the included adapter to easily connect it to your breadboards. Let's start with that. But before we do, here is the schematic for the clock circuit that we will be making. It consists of 3 555 timers and some extra logic there to tell us which output to use, I believe. And this tells us how the actual chips are, what the schematics of the chips are. How to actually use the chips, it doesn't actually tell us that, but it tells us what they are and what their input and outputs are. So, let's start with powering this thing up. All right. Hey, look, it's a breadboard. Oh, so shiny. What is this? This just... Sure, that was incredibly good on the microphone. I have no idea what the thing is. What is this with this? Oh, adhesive tape for attaching to a surface or a metal plate included. Okay. Yeah. I mean, I could peel it off and put it on a metal plate, but I don't know why I would do that. I'm gonna put this back in the bag, and I'm gonna put this back in the bag. Baggity bag, bag, bag. Bag noises. All right. Get that box. Ah! It's just me taking care of trash off screen, you know, like you do. All right. So you got a breadboard. Let's make sure it's the right way on camera. There you go. From 0 to 60, or 0 to 60. 1 to 60. Oh. Yeah, I don't know why I thought that was 0. I'm a dumb. But we're going to do it like that so that we can read the numbers. Let's see. I'm going to hook up this. Yeah. I will actually take all of these out, but for the moment, this is what we're actually looking to hook up with. No, wait. Phrasing. Okay. I'm just gonna pop out this. Oh, look, it comes in a nice little case and everything. Oh, yeah. So this doesn't actually contain those nice twisted pair wires that he had in there. So actually, I think I am going to... Oh, I'm sorry. These nice twisted pair wires here. I think what I am going to do is... I can either make them, or I can use some of these. And I think using some of these is a terrible plan, because these are so nice. I'll pop this open. It's been a really long time since I've had one of these kits. I mean, I never really actually had one as nice as this. The kits that I had, the one that I had that was the nicest like this was, didn't belong to me. It belonged to my school, because that was part of the digital electronics course that I took. Which was when I really started to enjoy, there we are, I really started to enjoy my computer science and really understanding what why computer science was a science and not just engineering. This is a lot of engineering, but, alright, let's see. Got this old kit that I bought at like a Radio Shack, many years ago. Yeah, let's use these. That'll work. I don't actually need this one because that's going to be a little long. But what I'm going to do is I'm going to strip off the ends of this. Well, it is not going to be a fun thing, huh? Because what I want is I want it to get into here. Let me get my screwdriver. I'm realizing I don't have my whole kit with me, but let's see if this will fit. No, this one's too big. Hold on. Gonna go grab my iFixit kit. Hey, how's it going, Seven? Give me 1 sec. I gotta go grab my iFixit kit from my bag. So I have a screwdriver. All right, now then. There we go. I also brought over this wire stripper that I've had from my dad for ages, that I haven't really actually used much. But I want to see how this goes into. See, I knew it felt the wrong way around. Let's see. All right. I can't recall how this type of... yeah, there we go. Okay, so I just tighten it up in there. Yep, all right, good. It's been a while since I've used this type of thing as well. That wasn't one of the little quick connect ones. Actually, I'm realizing I could probably just do this and it'll be janky AF, but it will technically work. Let's get that nice twisted pair going though, because, you know, twisted pair cable is nice. All right. And it's done for a reason. We're gonna talk about jank though. This is the jankiest of jank. All right. Ugh, that's not right. Hold on. Yeah, get that there. Yeah. There we go. Yeah. All right. There we go. That's not bad. All right. Let's see. Positive here. Negative here. Let's see, because this will actually, I think this will actually work great. Yep, so positives there. Negatives here. Oh, realize I can't see that angle. All right. I think I can put this away for forever now. Don't think I'll ever need that again. Hashtag not sponsored content. Seriously though, those iFixit kits are really nice little screwdrivers. I'll get this nice and tight. Tightly twisted wire. There we go. All right. Now then. Oh, actually, let's put it in a little bit. All right, there we go. That's a power we've got there. Let me just actually get the power plugged in down below so that I don't have to do it in a moment. And we'll see if an LED will get powered from this. First step, make sure the whole thing works in general. All right. You can probably hear a bunch of my chair rattling, even more than normal, and I know that my chair is already very loud. Whoop. All right. Grunt, old man grunt. All right, let's see. Does this shut off the stream when I plug it in? It doesn't. Okay, so I haven't massively destroyed anything because this is in the same circuit as the computer is. All right. Oh. All right. So I don't need these wire strippers after all, so that's good. Let's see. First thing, let's get the rails going across to the other side. This doesn't have any black. This doesn't have any black in it. Why? All right. And of course, it's just slightly too wide. Turns out I will need those wire strippers after all. All right. Depends on how. Oh. There we go. Depends on how neat I want to get this, and I would like to get it as neat as possible. Oh, hey, did I plug these in back? I plugged these in backwards. Oh no, I didn't. I had it plugged in correctly the other way, but this way it's a little different. Okay, because the positive is always on the top side there. All right, let's see. Positive, please. Positive. Okay. See. Now I have to deal with that bend. I don't want to deal with that. All right, give me a sec. How do we do this the most neat way possible? Where are my pliers? I have pliers over here. All right, let's see. These are not the correct size for this. There we go. Yeah, there we go. Okay. Let's see. Those wire strippers. Haven't had to cut stuff like this in a while. Let's see what gauge is this. Oh, it's not 16. Is it 18 or is it 20 to 22? It is indeed 18. Oh, wait, no. Depends on how you're counting this. I suppose this is 10 gauge, 12 gauge, 14, 16, 18. So yeah, this is 20 gauge. Okay, yeah. Let's see. Pull it through with the pliers rather than struggle like an idiot. Hey, look at that. We have stripped a wire. I feel so accomplished. It's my wonderful accomplishments. Boop. Let's get that. That was not what I wanted. That was not where I wanted it. There we go. I know how to use wire strippers, I swear. It's just been like 10 years. Straighten that out. Come on. Straighten out. There we go. There we go. Straighten out. Turn that 90 degrees. Hey, look at that. That looks pretty good. I mean, it's not perfectly straight, but, you know, hopefully. Oh, it's just a tiny bit under this size. But, all right, yeah. You know what? I'll take it. That's damn close enough. Now, I don't have any black. I have no black straight wires. Hold on. How's the focus on this? Is focus still slightly off? I want to be able to read the numbers. Meow. It's not quite as close as possible. Alright, yeah, I think that's as close as I'm gonna get it. Anyway, alright. I don't want to use green. That just seems wrong. But I don't have any black. I can't believe I'm gonna use red for the same fucking thing. Alright, cool. Red and red. Okay. Let's measure that out again. It's gonna be the same length, so. Oh, right. I can actually just put it in. See, if you watch Ben Eater's videos, this is the part that he skips because he's editing them like a smart person instead of like me, who's streaming this, so he looks like an idiot. All right. Should probably straighten this out. Doing this at slightly further than arm's length, which makes it just uncomfortable enough to make it awkward. All right. No, strip. I put in the wrong one. Hold on. There we go. All right, there we go. And clip. There we go. Okay. The fact that clipping it just turns it a tiny bit is slightly frustrating. Oh, whoa! Okay. I was waiting to see how long it would take me to hit my my camera. The answer is that long. 29 minutes. Come on. Oh, don't be too short. I did one too long and I did one too short. There we go. Okay. All right. That's good enough. That should get power across to the other side. All right. Let's see how we're doing on that. I have my multimeter here, right? My multimeter. Loud noises. All right, I got my multimeter here. I'm gonna call it that because this is a USB cable. This is a USB cable. That's not what I wanted. All right. Oh, right. I don't have the ones that can go inside, so I guess I'm gonna use these after all. Woo-doo. Oh, yeah, I forgot I had I pulled the end off of this one for a reason. Let's move this out of the way and this out of the way. We'll plug this in. Nothing has exploded yet. see if we can get, well, it's going to be -5 if I do it that way. Hold on. Look at that. Ah, stay there. 5 volts. All right. Let's check the other side too. Five volts. Okay, good. Power is working. Boop. Okay. Which, now that we know that power is working, we can put in some LEDs and stuff. Oh, this is slightly bent. That's not good. There we go. That's a little better. Let's see. What are we gonna put in? We're gonna put in a yellow LED. Yeah. Yeah. I swear I know how to use the tools that I specifically set aside because they would be fine. Let's see, we've got a yellow LED. Oh shoot, which way is which? I think the long one is the anode and the short one is the cathode. See, one is slightly longer than the other. I think the long one is the anode. I always screw this up, so I remember screwing this up for years. Let's see. LED, 220 resistor in series with every LED anyway. Yeah, that's fine. But that's not actually what I'm asking about. Shoot. Alright, let's literally just look this up right now. Yeah, cathode and anode. The long one is the... Which is the long one? I mean, it literally won't work the other way, right? The long one is positive. The long one is the anode. Okay. Alright, good. So the long one's the anode. So let's take a resistor as well. I don't know why I keep trying to open that the wrong way. Yeah. Yeah. Let's see, which ones are which? Okay, I know there's a chart for deciphering these. I'm literally just going to look at it. 220 is red, red, brown. Red, red, brown. I'm going to... Oh no, I don't have a pen. Well, I was gonna write that down on them because that seems like a smart way to remember that, but okay, guess I'm looking that up every time. Whoop. Pretty sure that this is kilo ohm, mega ohm, kilo ohm, mega ohm. But we need one 220 at the moment. So let's see. Resistor from positive to here, and then LED from here to here. Yeah, let's go across here. That'll be fine. And oh, I actually am gonna zoom this back in now. That might be a little much. Yeah, there. Wait for the wiggling to subside. Make sure focus is still good. No, focus is not good. There we go. Yep. We'll leave focus at that. Okay. So, and we'll need to connect this up to ground. I'm still so annoyed that there are no... Actually, since there are no, since there are no, since there are no, black cables, I will connect the resistor to, I'll connect the resistor to, ground. Alright, and then I will connect this. Oh, what? Orange? What? Oh my gosh. Need to get some Need to get some of my tweezers out. Jeez. Can't believe I'm using pliers to frickin'... Not even needle nose pliers. Just pliers. To pull this out. Alright. Alright, let's see. This should turn on and not burn. It doesn't turn on. And it doesn't burn, so that's good. Do I have it in the opposite way? Or did I not have it in the right way at all? Okay, I mean, I know I had the right voltage, right? Pretty sure I had this in the right holes. I do. Oh! Ah! You know what I did? Look at this. Look at this. They're both going to power. Or they're both going to ground. I really should go get my needle nose pliers. They'll look nicer. Hold on. Tweezers. The smaller ones are. I seem to have misplaced them, which is not unusual. I don't know where the smaller ones are though, so big ol' needle nose pliers it is. Whoop. Ah! Stop hitting the camera. Alright, let's try that again. Let's get the correct size one of these. Red, give me a slightly longer red one. Oh, the red ones are only short. Oh. The red ones are the shortest, and then orange, and then yellow. That's why, because they're color-coded for length, but not for use. Okay, then I think I actually do need a red one. Or, I'm sorry, a yellow one. Let's see. Yellow power for my yellow LED. Oh, let's pop power out of this. Oopsies. That's, you know, always good to do. Leave your power on while you're working on an active circuit. And this should turn on. Hey, look, it turns on. Hey, okay. I have an LED that turns on. Okay. Now for an even less boring circuit. Let's stick this in here. Oh, this literally just connects one side to the other, right? So I don't want to short this out. So, no. This is literally just a button. Oh, geez, my head just hit the friggin' microphone. I was not expecting that. Okay. This is literally just a button. We'll put the LED here. And we'll put the resistor here. Though I actually do want to clip this resistor in a moment, but I hate having the resistors up high like this. But let's see. This does not turn on. Hey, I can make a button. This is the world's easiest thing. Okay. Boop. Unplug that. So, the schematic for this is much more complicated though, because of 555 timer. I'm just going to read it out of this because I am not the best with the words on the fly. A 555 timer can act as either a timer, an oscillator, or a latch. In this project, we use all three modes to build our computer's clock. So, yes, you have the ground and the power. This is control voltage, threshold, discharge, reset, output, and trigger. Okay. I forget what all of those do. Let's see if we can figure it out from the schematic, because I know all of these, but the 555 timer is, as you can see, a little bit more complex. It actually uses a couple of transistors to do other things, and some NAND gates and stuff. All right, anyway. I'm sorry, that's not a NAND gate. That's a NOR gate. So, I'm going to take a look at this. Let's see which one is the first one that we want. Yes, they're decoupling capacitors. These help smooth out changes in demand for power. Place the 10 microfarad capacitor near the connection to the power supply. Spread the 1 microfarad capacitors across the entire project. Okay. It's been literally a long time since I've watched these videos, so we're gonna figure it out together. All right, we want manual clock control is the one that we want to build first, because this is the one that we want to be able to push to get to go first. This one is the automatic clock, and this one here switches between the two. So this is a latch, this is an oscillator, and this is another oscillator. I don't know, timer, latch, oscillator, I suppose. Okay. Actually, yeah, do we want to do the automatic one, or do we want to do the manual one first? Let's do the manual one. So, let's get out one of these 555 timers. Just already making a giant mess of this space. Where are the 555 timers? Oh, right. They're in here with everything else. I do like these little IC like tubes. I straight up do not know what these are called. I actually have one over there, full of I think they're D flip-flops, maybe D latches. I think they're D latches. Will you come out? Thank you. All right. So let's get one 555 timer and put the others down. So this is 555 timer. Let's see. Place it right in the middle. Whoop. Okay. So first thing we want to do is we want to connect ground and power. So, making sure we understand which side is which. There's a little notch. That side is the side with the ground and the power on 1 and 8. So ground to 1 there. All right. Let's see the orange ones here. That'll work. So orange to ground. Oh, no, I'm sorry. That's my bad. I want one of the yellow ones. Yellow. So this is going to ground. Oh, I am unplugged right now. Just good to check that. Let's pull this a little closer. I'll hook up ground. Oh, I suppose I could have done an orange one for this, but no, yellow is exactly the size that I wanted. Okay, and then another yellow for the other side. Where'd my music go? No, yes, continue watching. Don't pause my video. Thank you. All right, yellow. All right, so we've got our ground and our voltage hooked up. I'm gonna fold this in half. So let's see, we want to have from the control, I'm sorry, is that the control voltage? Yeah. From the control voltage, 5, we want that to go through a 0.1 microfarad capacitor, which is, I believe, these ones. Let's just double check that. 103. Wait, one is 104. Oh, this one is 103. And 104. Wait, really? Really? These ones sure look like that. And these ones sure look like this. I mean, like, size-wise, these two, this looks like 104 and this looks like 103. Let's see, does my multimeter have a, my multimeter is not fancy enough to have a, capacitance, a capacitance rating on it. And actually, wait a minute. That one does look like it says 104 on it. I prefer it. I'm sorry. I didn't have any of that on the screen. Look. These ones look smaller and darker. These ones look lighter and larger. But these ones say 103 on them, and these ones say 104 on them. And I'm not sure which is which. And it's important because the capacitor is what is going to build up and then discharge that circuit. Let me look. Yeah, 104 is the 0.1 microfarad. 104. So all right, so 104. So I think these ones are actually our 0.1 microfarad, and these are, yeah, or I'm going to say 10th of a microfarad and 100th of a microfarad. 0.3. Yeah, all right. 103 and 104. Mouse or electronics? Nope, I wanted pictures. Thank you. Yeah, 103 for the 0.01. All right. So they've either got a printing error, which I think is unlikely. I would think that if anything, this would have the printing error, but I'm gonna go by the numbers on the thing and not the pictures, because the pictures I know can already be deceiving. So, what are we looking at? We want to get our 555 timer there. So, though I don't think that the control voltage is the actual important bit. This is all voltage. This is all this logic here is just to differentiate between automatic and manual control. So I can skip all of this and go out to the clock here, and this can go to a clock LED with a 220 ohm resistor and go straight to ground. So backing up through here, Q is our output. That sounded right. Number 3 is output. All right, let's hook up our output to. I know I jumped subjects and decided to go for the output, but where's it? My LED. Let's take this LED and move some stuff out of the way. Try and. Wow, that was probably very loud. Sorry. Our LED here, number 3. Oh shoot, what direction does it go in? From the left down, counterclockwise. So our output goes to number 3 here. Number 3, there we go. Number 3 is going to go through a 220 resistor to ground. So where's my 220 resistor? Here we are. I think that at this point I will start clipping these. So let's see if we can do that. Is that the correct width there? It is. Yeah, that's like the exact width. Oh, but I need to go to ground. So, good thing I didn't immediately cut it like an idiot would have, you know. Me literally all of the time. All right. So, let's see about clipping this. Just use the wire cutter for consistency's sake. Yeah. Come on. Oh, it did it. It's just still stuck in it. I was waiting for it to loosen up on this side, and it loosened up on the other. That's really funny. And the same length, please. All right, there we go. Come on. Come on. Yeah. It's an old rusty wire cutter, and you know, I can't complain because it was free. And by free, I mean I'm pretty sure I stole it from my father. All right, there we go. Let's see. So that will give us our output. I'm not going to commit to cutting the LED yet, but this will give us our output. But first, the actual timer itself needs to actually be able to oscillate properly, and so 0.01 microfarad, which is the 103 microfarad, the 103 ones. This is a 103 one. I should have just, I had scissors down here earlier, and I should have just kept the scissors. All right. So let's take a 103 microfarad. Yeah. There we go. Nope. Knocked over something. That's fine. All right, toss these back in here. So 103 microfarad. This is going to the control voltage, and we need one that's going to be coming from the all right. I'm trying to remember exactly how 555 timers work. The discharge and the threshold. No, there's a 0.1 here. So yeah, let's do the control voltage out of port number 5. Oh, gosh, I do a lot of networking. Okay, out of the hell is the term for it? Hookup number 5. Gosh damn, why can't I think of the proper terms? What the hell are the integrated circuit teeth called? What the shit? Why do I have to Google this stupid term that's not in my brain? The integrated circuit. What is the damn name for it? Pin. Thank you. Gosh damn, my brain is slow sometimes. All right, so pin number 5. So 1, 2, 3, 4, 5. So this should be here, and that goes straight to ground. It does not matter which direction this goes in. So I'm gonna just pop that in there. There we go. So the control voltage goes to ground. The trigger, it looks like the trigger and the reset. Okay. So the trigger, this button is tied to ground here, right? So the trigger, it looks like, is probably tied. The trigger needs to go to a low voltage. So I believe the term is that it is tied high. So the trigger, when I press this, will go to 0 volts, and it is connected to a 1K ohm resistor to power. So when it goes to 0 volts, then it is going to trigger. The reset here is always going to be tied high. Really, the reset is always tied high, but not through this resistor. I am going to check the internal schematic of this 555 timer. Yeah, So it's got an AND gate in here. Or I'm sorry, it's got a little NOR gate in here, which that NOR gate probably has a resistor on it. But, oh boy, I don't want to actually touch that. This is a Q flip-flop? I'm sorry, it is an SR latch in here. This is a Q flip-flop. Fucking, I don't know what I'm talking about. This is an SR latch in here. So it's literally the 5-5 timer could be made with a transistor, some resistors, an OR gate, and some OR gates and some NOR gates and an SR latch. So it's just a single chip that does all of those things in a specific orientation. So, right? OR gate? Yeah. Inverter. Oh no, it's not an OR gate. What the hell is that symbol again? I straight up do not recall what that symbol is, because it looks like the inverter symbol. It's got a positive and negative on it. Jeez, it's been a long time. But that's why I'm playing around. What is the 2 inputs to a triangle? Nope, everybody wants to give me 1 input to a triangle, which I know what that is. Oh, it's an amp. It's an amplifier. Okay, an operational amplifier. That's why I didn't know what it is. Yeah, it's just taking the signal and so yeah, it's a transistor. It's not really a transistor. It's a transistor. Okay. So let's see. We've got 1, 8, 3, and 5 hooked up. Let's see. Reset. We're gonna hook up to the 4 here. I am going to tie this reset. I suppose we want the reset above the or closer to the voltage. We want it tied high at all times, I suppose. So I will do that. I will tie that high. The reset is number 4, so number 4 is here. Let's see. Is the orange the correct one here? I believe it is. Tiny hands. Tiny fingers. I do not have. Alright. There we go. Nope. No orange. No, not in the ground. In the source. Thank you. There we go. Okay. Separate those a little bit just so that... Oh, there we go. Separate those a little bit just so that we have the... Alright, so number 4 is tied high. Then we're going to take a kilo ohm resistor, which I believe is the red, black, brown. Kilo ohm resistor. Red, black, brown. Brown, black, red. I always do it backwards. All right. There we go. Look. Brown, black, red. And then gold is on the end. So, all right. So this is a 220. This is the kilo ohm. This is the mega ohm, which is brown, black, green. Brown, black, green. Yep, cool. Gonna stick these in order off screen so that I can easily get them. My schematic. So we want a kilo ohm resistor. A kilo ohm resistor that is going to go from 5 volts to the switch, and then the switch is going to go and connect to number 2 and ground. So number 2 is going to be connected through the switch to ground, and it is going to be connected. Yeah, so the left side of this is going to be the kilo ohm. Or actually, no, I can do whatever side I want. I'm just gonna pop this around here. I will trim it up and make it look all nice in a moment. Or in a while. Who knows? Whenever I get around to it. Okay. Still doesn't do anything. So we've got this. The button is tied through a resistor to high. And then I believe that both sides of this button are tied together, I believe. I'm pretty sure that's right. Hold on. Yeah. Yeah. These two are tied together, and these two are tied together. So, yeah, let's see. We've got that, and I need to tie it to number 2 as well. So number 2. Let's grab this. Is this the right size? Is this the right size? It is close enough. Number 2, tied to the button, tied high. So the trigger is tied high, and the button will drop that to low. Orange again. The button will drop that down to low. Oh, no, I'm sorry, yellow. I need a yellow. The fact that power isn't consistently inside or outside, but it is instead always top or always bottom. I would like it to be always inside or always outside, but no, here we are. All right, so there we are. Okay, so 2, 3, 4, and 5 are all hooked up. Yeah, 1, 2, 3. Oh, I'm sorry, not 4. Yes, 4 is tied high. 5 is through this microfarad. Through this capacitor is down, tied to ground. So number 3 is the output. Oh, I'm sorry. Yeah, 1, 2, 3, 4, 5. So 6 and 7 now are the only things. So discharge and threshold. So they are tied together, and they are tied with a 1 mega ohm resistor high. I'm sorry, 1 mega ohm. Yeah, 1 mega ohm resistor high, and a 1/10 of a microfarad capacitor low. Okay. Let's grab the capacitor. No, let's grab the resistor first. 1 mega ohm resistor. 1 mega ohm resistor. That is tied high. So that is on port number. Oh, they are tied together. I'm sorry. Let's do this first. Let's tie them together first. So 6 and 7 get tied together. Yeah. Go in. Go in. Go. There we go. They get tied together. Yeah. All right. So they get tied together, and then I'm gonna move this a little bit just so that I have a little bit more room here to work. And then this ties them high, and oh, I'm realizing I'm going to need a lot more room here. So that ties them high, and then what ties them low? We get one of our other capacitor friends here. Don't cut yourself, Kevin. Alright. So I need to not have any of this touch each other, which is why I'm gonna clean it up in a moment, but this ties low. Okay. Alright, there we go. This is 1/10 of a farad. The size of these is always odd. All right, so I believe that we have our entire circuit here. Let's see if we blow anything up. Oh, okay. Look at that. Okay, so it doesn't have a latch. Is this actually a latch that I'm building here? Let's see. No, take the inverted output of this and take this. No. Yes, this or this. And it goes out. Yeah. So, all right. So the clock will this will click one step. It will go move. It will give us one high and one low. So this will move one. It's not going to invert it, but it will. That's really funny. I have a button. It's a very fancy button. Is that right? Yeah. Yeah, I'm pretty sure that's what this is supposed to do. Is that what this is supposed to do? This is literally just a button. Yeah. Well, listen, nothing's exploded. Nothing feels hot. So you know what? I'm going to take this as a win. I'm going to take this as a win. The discharge and the threshold being tied together is very odd. Nothing's hot. Hold on a minute. Am I missing something here? Am I supposed to be doing something even more straightforward? Hold on a minute. Hold on a minute. I feel like yes, thanks, Ben. Yeah, because the automatic one goes on and off. Yes, clock logic part 4. No, clock logic part 3 maybe. I feel like I've done something slightly wrong. Yeah, no, I'm taking a look right now at the video here. I actually do have this tied up, not exactly how he does, but damn close. And yes, it just goes on and off. I think that's this might be part of like a debounce. Yeah, I think this is actually a debounce circuit. Hold on a minute. I was wondering about where the debounce bit was. So I think that's what this is. It's just a debounce circuit. So that's fine. Listen. It's a button. Okay, let's do the actual exciting bit of this then. So let's see. Let's take our other wait, should I clean this up first? Yes, I should clean this up first. Oh no, shoot. I hope I did not burn anything out. I didn't. I didn't. Oh no. This was, yeah, everything was tied high through this. Everything was tied high through this. Okay, let's make sure this still works. Yeah, okay. No, we're good. We're good. Okay. Let's clean this up nicely. Let me use my other let's see. Oh, that was so much nicer. I'm not going to use the wire cutter to just cut wires. The wire stripper to cut wires. There we go. That was so much nicer. Whoop. There we go. Let's do the same thing with this one. Get it nice and straight. There we go. Oh, hold on a second. This is out of focus too, I'm sure, which is not helpful. Yeah, actually, I did get it punched in enough that did work. Okay, I scored it enough. Perforated? I think the word I was looking for was perforated. Okay, so that ties that high. Yes, perfect. Okay, let's get tied low. Port number 5. Tied low through this. Yeah, that'll work. Let's see what we can do about getting this to be a nice length. Yeah, that'll work. There we go. Oop. That's tied low there. Perfect. Perfect. And then we can get port number 4 tied low. No, I'm sorry. This is port number 5. Oh, wait. Wait a minute. Did I just screw that up slightly? I did, didn't I? This is supposed to be tying these other ones over there. I'm gonna have to move this slightly, I think. No, hold on. I don't know how I like that. Yeah, that'll work. There we go. So they're both doing their thing there. The resistor and the capacitor are just touching slightly, you know. Boop. Okay. Yeah, I don't like that. I don't like that at all. I think I want to move everything over one, but or I could just move this over one. There we go. That'll work. That'll work. Okay, perfect. So one is tying them home. One is tying them ho, and one is tying them high. Hey, Roger, it is going. I've got a button. It's a debounce circuit, but I'm pretty sure it's a debounce circuit. All right. This is number 5. Number 5 through this 100th of a microfarad. 10 nanofarad. There we go. 10 nanofarad. That's the term. Let's get this actually a nice amount here. Ugh, breaking the casing around it. I don't like that. All right. This is tied low, so yeah, let's do that. There we go. Sorry, cutting that off screen because it's going to be out of focus anyway. Guess you managed to get a 3070 RTX and get to check out when they came out. Holy shit. Oh, that sucks, Roger. Oh, I'm sorry. That's brutal. This is tied low, right? Yes, this is tied low. All right. There we go. All right. Let's just make sure that this still works as expected. It's a button. It's a button. Okay. I suppose I should cut the LED too. Yeah, let's do that. You're so fucking excited. That's really brutal, man. All right, if I don't actually get this perfect, I'm realizing I can just move the the resistor. I want to keep the long side long though, so yeah, let's do that. Let's do that. So that this side is the long side. Okay. Got metal shards all over here. From positive to negative. There we go. All right, we still have a button. We have a button, and it looks nice. I know that. I'm tooting my own horn here, but like, look how nice that looks. That's so nice and neat. I will take it. All right. Last hope for a card this year is the AMD 6080, and as AMD has finally gotten a card that competes with NVIDIA. I have heard good things about the 6000 ones that are coming out. Are they any cheaper than the NVIDIA ones? Because I mean, AMD I know is also dealing with Intel in a different space, and usually is the cheaper option there. All right, just cleaning up a little bit of my mess here. Please hold. All right, that can go in the box. This can go in the box. Excellent. There we go. The 6080 has the same cost, but with slightly better overall performance. Holy shit, that's crazy. All right, this is no longer a button because it's not plugged in. I unplugged it. All right, so let's see. Where's the next 555 timer? So let's do the actual automatic one, which is the actual fun bit. Oh, I forgot I had this in here. I'm gonna take that out. So let's see. Pop. I can do this in shot, please. If you have an AMD CPU, it can apparently squeeze out an extra 10%. Damn, that's surprising. You'll have to let me know how it goes when you get it, because I'm just going to assume you're going to get it. All right, let's see. We need to get power and ground hooked up. Number 1. 2 more yellows. All right. So let's see. Power on number 8. Let's see. Power. Ground on number 1. There we go. The scalpers will be just as bad with it as the NVIDIA stuff, so not holding out much hope. That's fair. Hey, you got close today. Let's just assume you'll get one next time, right? With the next rush sale. Are crypto miners still dealing with? No, I suppose they've got a slightly more specialized equipment that they're after, huh? So they're not going after the same like consumer like general purpose GPUs. They're going after very specific GPUs, right? All right, let's see. The control voltage is going to ground through a 10 nanofarad capacitor, which is the big ones. So, number 5 to ground. No, I don't like where I put this at all. Hold on a minute. This is almost as bad as the other one. Actually, this is probably worse than the other one in placement-wise. I feel like I should move that entire circuit over, but I will deal with that when I need to move it over, because I don't have enough room for all the AND gates. Not crypto miners anymore, just people and companies using bots to buy all the stock in seconds and reselling it for massive markups. Yeah, the scalpers, yeah, but not the crypto miners. Number 5 is going to ground. Number 5 is going to ground. And let's just do this a little bit right here. Clip, clip, clip. Number 5 to ground. There we go. Look at that. Number 5 to ground. We're good. So that's a control voltage. Yes, now this one, the threshold and the discharge are not linked. 1K to 1M. What is this? Is this the potentiometer? Clock speed. This must be the potentiometer. Number 6 is going to the potentiometer. No, that doesn't look right. I know the potentiometer goes in this circuit. Hold on a minute. Number 3 is our output. I don't want to build this yet, so I'm literally just going to move my LED. No, I'm gonna make another LED. Yep. Another LED along here. So let's see. All right. Let's see, we're gonna do that. We're gonna snippity snip. Actually, that's actually really good for measuring, I'm realizing. LED. Snipping that. Number 3 is our output. Yeah, we'll go here. That's our output. And that output gets tied to ground. Oh, whoops. Actually, I'm sorry. I did that the other way around. I need to go positive to negative there. There we go. And our output gets tied to ground with this. Uh-oh. I moved him around. Uh-oh. Yeah. This is our 220 ohm. One nice thing with the 6000 series is that all cards have 16 gigabytes of GDDR6 VRAM, while the 3070 has 8, and the 3080 has 12. Oh, wow! So it kind of straddles that middle of the road there. While yes, I'm still listening. Thank you. Straddles the middle of the road there of being better than most and only slightly lower than the top end one. So that's great, actually. All right, let's pop that out. Snippy snip. Yeah, come on, come on, come. Get off. This can go to ground. There we go. So this should show us the no, it's actually slightly too long there. I'm gonna snip that a little bit closer. Hold on. Snippy snip snip. There we go. Says vaguely Undertale vibes here. There we go. All right. There we go. So that should give us our output. Number 4 is tied high. There we go. Number 4 is tied high. All right, number 2. All right, two goes into the weird circuit, and I need to look up a picture of this. Oh, I don't need to look up a picture of this. I have a freaking picture of this because I can't quite figure out where the potentiometer goes. So we've got here our potentiometer, which it looks like I'm trying to view on the picture which side of the potentiometer is where. Hold on a moment. It is impossible for me to tell which side of this is which. Oh yeah, no, there we go. There's a dot in one corner. All right, so in this case, he has the potentiometer over here. I think that sounds like a great plan. Potentiometer goes right here. So the potentiometer hooks up to ground through a microfarad. A microfarad. I'm literally just going to keep calling them microfarad. Through a 100 nanofarad capacitor, maybe? Let's see. So the potentiometer hooks to ground. Oh, that's a microfarad. Sorry about the bonking. Move that off of the wooden table. Let's see. 5 goes through a 10 nanofarad capacitor. This has the 1 microfarad capacitor. So where the hell? Oh, place the 10 microfarad capacitor near the connection to the power supply. Spread out the 0.1 microfarad capacitors to the rest of the project. Okay, that's what it is. This is literally a 10 microfarad capacitor. I believe these are our 10 microfarad capacitors. And if we look on the top here, so this is his 10 microfarad capacitor. This is a 1 microfarad capacitor. And then he's got his other ones around here. So I believe that that's to smooth out those power changes, the decoupling circuit. The middle of the potentiometer, yeah, so there are 3 pins, but only 2 of them are hooked up on the potentiometer. Whoop. Oh goodness, I'm so sorry. You were talking about it, you decided to look into it more. In the first place, you just checked has them listed with different specs than what you saw last night. Oh no! Oh, I think that this is the potential coming to these and the potential coming to this between 1 and 2 and 2 and 3. I think these are both just different outputs or similar outputs. Oh, I gotta relearn what I know about potentiometers, which I don't recall what I know about potentiometers, honestly. But the potentiometer here hooks into, let's see, the middle one hooks into 7, and the right hand one, the middle one hooks into 7. The middle one hooks into 7 through a resistor, and the right hand one hooks into 6 directly. So let's see what that is on our circuit, on our diagram. Now you're just confused. All right, so 6 hooks directly in to this, and 7 through that goes there. Okay, cool. So, okay. So let's see about that. Pull that back a little bit. Okay. So, the middle one hooks into 7 through a resistor, a 1K resistor. Let's see. The middle one hooks into 7 through a 1K resistor. And the right hand one hooks directly, actually I'm gonna make a mess of this for a moment. There we go. And the right hand one hooks directly into number 6. So the discharge goes through the resistor, but the threshold goes straight to the potentiometer. And then that goes through our 1 microfarad to ground. So we'll put that in a moment. First, let's see what one we are going to need. Go 1, 2, 3, 4, 5. go 5 over. Let's see. He had a green in his picture. Maybe I'm somewhere around there. Is this the right size? Is this the right size to go from here to... No, that's way too big. Is this another yellow? Can't believe it. Literally just using all of the yellow. Okay. I have plenty. It's fine. But... And there are more that come in the other kits, so... Let's see. 1, 2, 3, 4, 5... yeah, close enough. Alright. So number 7. Pop that out. Number 7. Yeah. There we go. That goes to there. Okay. I'm sorry, number 6. Number 6 connects to the output there. Yes, good. Okay. Good, good, good. Okay. And then this all gets tied high. This all gets tied high with a 1K resistor. I just want to double check that on the front. Yes, that all gets tied high with a 1K resistor. Okay. Having pictures and schematics, it turns out very, very useful. Another 1K resistor here. Seem to be running out of these, and I still have a couple of other things to do. I need 2 more. Good. Okay, I have exactly enough. Let's actually clip this one. And tying this high, so... And clip. Alright. Feels so weird to clip resistors and stuff, because normally, you know, when I was doing this sort of thing, I was doing it using school equipment, so... you know, I was trying to not make changes to anything. Alright. Let's see. So we've got this from 5 volts to a 1K resistor. That goes to number 7. Through another 1K resistor, it goes to here, and then out to the potentiometer. And then from the potentiometer, it goes to number 6. Then from number 6, we need it to go to ground through a 1 microfarad resistor. So we've got our 1 microfarad resistor here. So number 6 should be going to ground. I can't believe I'm referring back to this picture this much, but yep, cool. That looks correct to me. Okay, where's my that was not smooth at all. That was even worse. Listen, I got it open, okay? Touch the camera. So number 6 here. Whoop. Positive to, yep, there we go. Good. Okay, big ol' honker there. We should put this in as well to smooth it out. Fine, we'll do it on this page. There we go. That's so much better. That worked much, much better. That's better. Much, much better. All right. So does this go right next to the power supply? Is that what I'm seeing? Oof. All right. All right. All right. Got that squished together a little bit there. I don't like that at all. Just don't short, all right? There we go. Okay, so there we go. We've got that. So now we're only missing number 2. Number 2 is connecting to... Oh, number 2 connects over here. Oh, so does he actually bring that around? Number 2 connects to number 6, is that right? Oh, yeah, through a 1 microfarad. Number 2 connects to number 6 through a 1 microfarad capacitor. And it's the same capacitor. Yeah, so number 2 comes all the way around. Okay. Oh, yeah, all right. Yeah, so and we'll put this over on the bottom. That'll look better too. Cool. It's very busy right here, so. Aye, Roger. Literally just seeing your message now, sorry. Come on, give me a something. Can I bring this around nicely? No, I'm gonna have to. Let's see what's the purple one's a little bit longer, but not much. Okay, fine. Let's see if the purple one will be enough. Let's see, bend this way. Okay. And then, it's not gonna be long enough. You know what? Yeah, we'll do this. This is really silly. We're gonna take up an extra circuit there. Actually, no. Let's I really gotta stop. Bumping that. Listen, it's very close. Okay. There we go. Let's do this white one instead. All right. That, and then that. How about that? Oh, 2, not 3. Uh-oh. Whoa. Yeah, that will work. We just need to move this one. All right. That in there. Yep, there we go. Good. And then this one. This one goes from number 2 here around to number 6. Oh, come on. Go straight down. Yeah. All right, there we go. Look at how nice and tidy that looks. Number 2 to number 6. Okay. And then we'll tie all of this to ground. Right here with this capacitor. Oh, that's to power. Hold on. Whoopsies. That would not have done much. All right. So that is the most complex part of that. All right. Yeah, let's see if it works. Whoop. It doesn't do anything. I don't like this. Nope. Okay. It could also be that the potentiometer is very, very tight. Oh, holy crap. That's so tight. Ugh. Yeah. All right, there we go. We'll try and put it as like halfway in between as we can. All right. So it does nothing. Nothing gets hot, but it also does nothing. So let's see what we did wrong. I mean, it could be as simple as the LED. All right, so port 1. Oh, yeah, no, port. All right, so port 1 is tied to ground. Behind this, yes. Port 1 is tied to ground. Oh, I'm sorry. Port 1 is tied to ground. Port 2 ties into this, and into 6, and into the output of the potentiometer, and the output of a potentiometer. Oh, Wait a minute. Yes. Yep, no, and the output of the potentiometer. Sorry, I thought I found it, but I did not. Okay, so then the potentiometer ties through a 1K resistor to number 7 and to a 1K resistor high. Oh, I'm sorry. A 1K resistor high. So that is correct. So 1, 2, 3. Number 3 is this LED. out to ground through this. Actually, you know what? You know what else we're gonna try? Okay, the button still works. So the circuit itself is powered. So let's see. Number 4 is tied high. Number 4 is tied high. That is correct. Number 5. Number 5 is tied low through a 0.01 microfarad capacitor. Okay. That's the control voltage. Port 6, again, we've already established, is tied to ground through here and attached to number 2, connected to number 2, and connected. See this 1K to 1 meg. This potentiometer here, this must be the symbol for the potentiometer. That's 1K to 1 meg ohms. Wait a minute. So does this mean that I actually should not be tying that like that? And that it is tied high otherwise. Let's take a look. Let's take a look at this picture here. No, yeah, so this has a from the middle pin of the potentiometer to pin 7 of the clock. There's a 1 kilo ohm resistor, and then to ground. Oh no, to power. Yeah, no, it's to power on here. Oh yeah. Oh, his is upside down from how mine is. That's why. To power. You know what? All right. I've figured it out. Well, the reason that this is not working is because this is actually tying the voltage to ground. So the circuit itself, the 555 timer, the 555 timer itself, the input voltage was 0. That would do it. All right. I can't believe that. I knew that I was going to make that mistake at some point, but all right, let's plug it in. It turns on. Hey, it turns off. Oh, hey, it's doing it. Hey, hold on a second. Where's my, where did I put my kit? Here it is. I'm just gonna use this has a little slot for a screwdriver, which is actually just pointing where it's going, I'm sure, but. All right, so that goes really slow, but and I think that if we replace this, I'm just turning the potentiometer. I think that if we replace this circuit here, this resistor. Thank you, Roger. I appreciate your praise. I will take it as well earned. I believe that if we replace this resistor here, then it will change the speed of it because the overall resistance is going to change. Let's try that. Let's change it out for a higher resistance first, just so that I don't really fuck myself over. And so it should go incredibly slow with this, because this literally we might not even see it change. Yeah, so this is literally, it's a mega ohm I'm sorry, it's a mega ohm instead of a kilo ohm. So it's gonna take a while. Is this the slower? No, I think that oh yeah, I think that it's at the slow speed right now. Let's see if we can. I think yeah. So I think if we swap out one of these, it will, because that basically the slow was unbearably slow there. So the question is, which one do I need to switch out to make it go faster in general? How do I make go fast? Which this will never go really fast, but let's see. This is the. It also seems slightly. No, okay, all right. It seemed slightly asynchronous for a moment, so it was like it was on longer than it was off. But I think I'm good with that. So let me see if I replaced this one here, because this is the one that I have going here. This ties it high. It's either the capacitor or the resistor that I can replace to make it go faster. And my brain wants to say it might actually be the capacitor that is might actually be the capacitor that is going to be the deciding factor there. But we've got a button and we've got an on off, and I'm gonna do some research offline to find out. And by research I mean watch his videos again. I'm gonna find out what I need to swap out so this will actually go faster, because I think it's going to be, I know it's either the capacitor or the resistor. I want to say that the lower resistance will give me more current through it, but I don't recall if the capacitor will charge faster with more current. I believe it will, but if we also put this at a smaller capacitance, then that could also do the trick. So it may be both that it will do it, but for the moment we've got this going. So let's see about changing this so that we get one output or another. I think I should probably move this whole circuit over a little bit. I should clip this so that it is the correct size. I'm sorry. I should probably move this whole circuit over and then clip this so it's the correct size. All right, let's see. Let's see, we need to go from the middle there to there, right? That is slightly too wide out then. All right, let's do that. Clip to clip, 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 clip. Clip, clip, clip. All right, what do we got? This is, there we go. It's actually a little bit high, but that's fine. And this is 1 microfarad. This is 10 nanofarads. Yeah, this is a microfarad? Yeah. Oh, let's try putting this back in, by the way, just to see if that smoothing works as expected. Okay, so yeah, so this is doing its job. Gotta go fast. All right. Okay, so this does what it's supposed to. So I'm gonna actually clamp it down there. all the bending. I am not good with wires somehow. Alright, there we go. You need to come in. Actually, I'm going to straighten this one out, so this one is clearly cathode, and then this one is the anode, which is slightly bent out there. Let's see. I know this is incredibly riveting right now. All right. Here we go. No. There we go. Well, I'm never going to know what is the anode and which is the cathode. Oh, right. There's a stripe on here? There's a stripe on here. That stripe is supposed to tell me that that's the cathode. I'm going to forget that. Come on. Come on. All right. Anode in, cathode in. There we go. I'm going to move that slightly over. There we go. All right. There we go. That sits very nicely there now. Let's just double check that everything still works as expected. I assume it will turn off and then back on. Excellent. Okay, so we made an oscillator. Gosh damn it, Roger. That was very good. And let's clip this down. Because I do expect to change this out at some point, but for the moment, let's oh, there we go. Nice and square. Hope that's square on the. Does that need to go to ground? That needs to go to ground. Shit. Slightly too soon on that bend. There we go. All right. Clippity clip, clip, clip. There we go. Still works exactly how I expect. All right, there we go. That works for me. Let's move this over so that it's closer to where it should be. So, I'm literally just gonna have to pliers this whole fucking thing. All right. Yeah, let's do that there. That looks like a great plan. That way this can be on this side here. And this can be right here. Shit. Yes. No, here we go. This needs to go to there. Oh, actually, I need to push this over a little bit more. Okay. Sorry, I need to rebuild this circuit while not losing where everything's at. All right, there we go. Because this is supposed to go to number 7, correct? And then the yellow goes to number 8. Number 7. Oh, I'm sorry. Oh, I'm sorry. 2 and 1. Wrong side. Yeah. Good. This goes to number 3. That goes to number 3. This goes to the output of the LED to ground. This goes to number 4. This ties number 4 high. Okay. Then this one is tying that to there. Good. Oh, sorry, I just bumped the mic again. I'm sorry about that. All right. Whoop, 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 whoop. Oh no, just bent all the pins out. Bent all the pins out. Well, you know, normally bumping the mic and camera is normally not something that I have to worry about, just like I don't have to worry about showing my disgusting hands. But, you know, here we are. All right, this one Oh, shoot. This is number 5 tying 5 low. All right, so this ties 5 low. All right, yeah, perfect. 5 low. This one ties 6 and 7 together. Good. This one ties number 6 and 7 to ground as well. So it doesn't matter exactly where that goes, but I'm going to put it there. No. Wait, what is this one? Oh, this one ties 7 as well. Yeah. So. Yeah. All right. We're getting there. Moved over the debounce circuit, I think. I think we're at the point at which we can say that this is going to be moved over. Let me just move the power as well. If I can ever get this resistor in. This ties this. Oh, wait, does this tie this high? This ties this high. I'm sorry. That's why I'm having trouble, is because I'm trying to fit it in the wrong frickin' one. All right, that ties that high. This ties number 8 high. All right, there we go. That's a circuit. This one still works. This is still a button. Hey, crazy old gamer. Yes, indeed. This is 555 timers. You are correct. I am about to put in my third one. So you can see we've got 3. One of which is the oscillator, one of which is literally just like a debounce circuit, and one of which is a switch. It's a latch. So we're going to use this as a latch. So, speaking of, that's actually what we're getting ready to do right now. So perfect timing. What time zone are you in that you're just waking up? Let's see. What do I need to tie to this? I need to tie a switch to it, but I want to make sure that I can fit these other switches as well. So let me just double check, because I have 3. I might as well drop the other 3 circuits in right now. So let's see. We need the and the NOR and the OR. I'm sorry. We're going to need AND gates, inverters or NOT gates, and an OR gate. So the thing that is going to go out last is the AND gate, but I'm going to put it in the middle, and then we'll go through the OR gate, and we'll put the inverters at the beginning, I think. You're an EST. Oh, I see. So crazy old gamer is not just a moniker; it is also a fact of your age and life. There, this is our OR gate. This is a 74LSO4, so that's our NOT gate. This is our AND gate then, which should be an LSO8. LSO8. Good. So let's put these in order as well, just so that I have them available to me. Let's put them from the right side over. Yeah, it's a description, not just a moniker. Nice. What's funny, it was watching Lucky Marine Gamer. I'm pretty sure it's Lucky Marine Games. Literally, it's LMG. He was up just at all hours. It was like he was in Britain, and so it was literally, I was just like, I realized he was going live at like 2 a.m. London time at one point. I was like, wait, what's happening? But anyway, all right. So we've got our gates there. I just want to make sure that we have enough space to be able to do everything that we need to here, because literally all of these are just tying power and ground, and then just tying them back and forth. So having them close together is not a problem. Just so that we can check. Yeah, I'm just putting this picture on screen. Incredibly relevant. So he has one space in between each of them, but not a huge deal. I will do that. That sounds reasonable. Because that means that I can run things in between them as well. So, all right. You know, I'm a complete amateur when it comes to doing this. Well, I'm not a complete amateur. I'm just a very, very, very out of practice amateur. So, you know, damn close. This looks like a Radio Shack kit from the 80s by the cover of that. So, yeah, I think that's kind of the idea. So this is a kit by Ben Eater. The entire, actually we can put it right here. The entire kit will eventually become this breadboard computer. YouTube.com/Ben Eater. I highly suggest if you find this content interesting, he does a very good job at explaining all of this and explaining why these circuits are the way they are when I'm trying to recall that from watching them a long time ago and just decipher them and recall what they are exactly. So this one is literally just a switch between a couple of these. I'm sorry, we're literally just using it as a latch, which is probably why the threshold and discharge are kind of getting tied to ground and stuff there. So let's start doing that. Let's see, we're gonna let's power it on first. We're gonna need some yellows for that. Oh, I'm running out of yellows so quickly. But yeah, he makes these kits, and they're not super expensive, but they're, you know, expensive enough that it's taken me probably a year and a half to a year to get the motivation to buy it. Do I do these types of streams a lot? I do not. This is absolutely a first. Yes, continue watching. Thank you. This is absolutely a first. Is a wild and crazy experiment. I've just been wanting to build this, and I figured, screw it. Thursday time is me time. So here we are. All right, there we go. So we've got power and ground in. Number 6 ties to ground as well. So 8. But 1, 2, 3, 4, 5, 6. So 6 ties to ground as well. I'm literally just gonna pop one of these reds over here. 6 ties to ground. Yeah. 6 ties to ground. 7 ties to nothing. Oh, I'm sorry, that's 8. That's 8. Whoa, whoa. Never mind. I almost just tied 6 to power. No, we want to tie 6 low. It's fine. We can use this orange if I can ever get it in there. Let's proceed with the sex jokes. Yeah, I mean, oh, I'm sorry. I just totally just yelled into the microphone. I love this sort of thing. It's something that I really enjoyed while I was doing at college, and it's something that I haven't really had a chance to do much with in general. So, though it's technically not analog, this specifically is technically digital. But yeah, this sort of like low level thing, I really like the idea of playing around with it. So here we are. Let's see. 1 to ground. 2 is going to our selector switch. Where is it? Here it is. So we've got this selector switch, which is going to 2 and is going, between 2 and 4. So between 2 and 4. So 2 and 4. So, do I want to put it up here or do I want to put it down here? Oh, you know what? No, I'll put it down here. What is number 4 tying to? Number 4 is tying to this, yeah. So put it down here. Number 4, and then it's tied. This is tied high through 1 kilo ohm resistor. Alright, this is tied high through 1 kilo ohm resistor here. This is kind of your full-time hobby. What, this sort of thing? Or Twitch? What is your I mean, you said that you're tired, right? So what kind of stuff do you do? Oh, just building things out of spare parts. Very, very cool. I have to tie this to power here through this 1 kilo ohm resistor. Actually, I'm sorry. I want to make sure that's connected to number 2. Yeah. So number 2 is connected to power and then also connected to this. So yeah, so let's connect number 2 to power instead. Let's do that here. Yeah, because the output of this, the output of this is going to ground. Is that right? Yes, I'm sorry. The output of this is it's connecting either reset to ground or trigger to ground. So and so that'll make the latch. Okay, cool. So number 4 is connected there, and number 2 is connected high, and number 2 is connecting to the other side of this, which I'm realizing like I may end up doing this one backwards. Oh, that's very cool. Sorry, I'm picking out one of these. I saw that Home Assistant is, oh gosh, yeah, I'm completely out of yellows if I do that. Okay. Home Assistant has like these 3D printed NFC tag readers that seem super, super neat. I actually have a use for the wire cutter again, the wire stripper again. That I was kind of thinking about. It would be nice to get at some point. Yes. I need to make sure that I'm actually doing this on the correct. Which side I'm doing this on. I want to make sure that I get the right distance here. Pop it out. Yep. Cool. Okay. Yeah. I literally just need a tiny bit off of this. Need to strip a tiny bit off of this. There we go. All right. Use the pliers to pull the wire through. Don't try and use your hands because you're not going to get it. All right. There we go. There we go. Let's see. There we go. Number 2 is tied to one side of this. Yes. Number 2 is tied to one side of this. Number 4 is tied to the other. Excellent. And then the base of it goes to ground. Which I need a yellow. Shit. Okay. You had to look it up. NFC tag readers are iOS. Well, I mean, iOS has an ability to do it, yes, but the idea is that it was a standalone object that you could use if you did not want to use your phone for whatever reason. Which there are many reasons for putting it like the original impetus, I believe, for Home Assistant integrating NFC was somebody who made little album cards, and so it had a like picture of the album, and they would scan it onto an NFC reader that was like built into the table, and then it would play that album on all of the speakers in their house. And so Home Assistant looked at that and was like, hey, that's an amazing idea. Let's try and make this a lot easier to do, so that you don't have to go through like your Raspberry Pi and with an extra NFC reader and like process it that way. Like, let's just process it straight through Home Assistant. Yeah. Anyway, I know I've started rambling again, but here we are. All right. So one. All right. 2 is tied high and connected to this, and then number 3 is the output, which we will get in a moment. It goes into one of the AND gates. So number 3 I'm skipping for the moment. Number 4 goes to the other of this. Oh, and is tied high with a resistor here. Okay, so I'm going to move this up. Tie that high. And where are they? Oh, all right. This is my final kilo ohm resistor. I think I have some lying around if I burn one of these out, but this is the last for the moment. Anyway, all right, there we go. That should work. Oh, yeah, that's right next to that. I'll cut that down in a minute. Number 5 takes this. No. A 1 micro ohm. Nope, not 1 micro ohm. A 10 nanofarad capacitor. There you go. Same thing, that's out of number 5 of the others as well. Yes. Okay. This one I will clip immediately. Okay. Number 5, tying that to ground. Number 6 and number 7 are already done, because number 6 goes to ground and number 7 doesn't connect anything. So we're literally just connecting our output, number 3. So now we get into the interesting logic here. So let's see what this takes. HLT. Oh, halt. So this halt is literally just a where are we? Here we are. Literally just takes an input, changes it to. All right, so let's see. If we want this to run, then this AND gate needs to be up. So that means that this needs to be high, which means that halt needs to be low. So if we turn halt high, then it will shut it off. So here is our halt going to our NOR gate, and we'll, I gotta get out the schematics for this. Our NOR gate, we'll choose number 6, number 5 and 6. So that will be where our halt is. Let's tie our power and ground on each of these, which I'm out of the correct measurement for. So here we are. Power. I could turn them around, I think. I could turn them all around. Or I could replace the ground here on the other side. Yeah, let me do that. I'm going to replace these ground with orange. Replace these ground with orange, which is just going to look awful. All right, awfully confusing. But yeah, come on, go in. Come on. There we go. Come on, go down. Ah! I can't do it. I can't do it. It's just too short. But the yellow ones are the exact right length for every single one of these, which is so frustrating because I don't have any more of the yellow ones. So I guess we're going to use these green ones and just do it that way. So green. Just getting a bunch of these greens. Here we are. That's a blue. Hey, have a great night, Roger. Thanks for stopping by, man. Alright. Let's see, we want to tie this one high. Yeah, this is way too long. Maybe we can get it just to go into one hole. Yeah, skip over one. That'll work. Okay. Tie these high. Oh, I knocked the camera again. High. And high. Yeah. Nope. There we go. Then low. Low. All right, low. And then this one, actually. There we go. Yeah. We tie our halt low for the moment, and it will be fine. Okay, so let's see where we want to go with this. Well, let's pick our AND gate that's going out to the entire circuit, to the entire clock. I'm not going to worry about this anti-clock circuit for the moment. I'll have to add that in at some point. Well, literally, it's just going to tie it to another one. So I'm not gonna tie it into anything, but I will connect it in. So let's see. The AND gate that goes out to our clock, we're going to want to put an LED on the end of that. And we're going to use the blue LED for that. Yep, there we go. Blue LED, one of these, please. All right, one blue LED on the output of one of these AND gates. Oh, it's telling me specific ones to go to, which I suppose would be nice. I don't technically need to do these, but that is nice that it tells me, so I might as well do that. So, of my AND... Oh, wait. My middle is AND. This is my NOT. Whoops. NOT and or. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. That doesn't seem right. Yeah, 8 and 9. 8 is the output. Yeah, 1, 2, 3, 4, 5, 6, 7. Oh, I'm sorry. I'm off screen again. 1, 2, 3, 4, 5, 6, 7. So 8 is an output and 9 is an input. So yeah, let's actually tie that to the one that it says there. We'll tie that low. So 9 and 10 going into 8. So 8 is here. Yes, clock LED, your 220 ohm resistor, positive out the 8. Yeah, let's do that. going down, tying that down with tying that low with a 220 ohm resistor. There we go. All right. So in theory, going into this AND gate. Oh, so let's do the output of 8 into 10. So 8 into 8, 9, 10. So yeah, let's do that. Let's see. Slightly too long. The white is slightly too long, so I think purple might fit this. Let's see. What of 8 going to 10? Yeah, or going to, yeah, 10. Yeah, nope, that's right. Okay, good. So there we go. So our halt currently goes there. So let's see if we tie this together, ignoring the rest of the logic. If we tie together our output, oh, right, I forgot that this is a jank one. Hold on. Uh-oh, I need to pull out my other kit. Let's not do the jank one. Let's do a. Oh, here we go. Actually, I've got a couple in here that are different colors. So let's not use red for this. Let's use yellow for our halt. That actually has 2 yellow there, so that's perfect. Alright. So we want to tie this low for the moment. Yeah, there we go. That's our low. And then we want to take our input to this AND gate here. We want to take whatever our input is. So let's do our manual input for the moment. Don't fry, don't fry, don't fry, don't fry, don't fry. So this is not going here. Why is that? Low, high, output to clock LED. This is low, which means the output is high. And then we have the output of whatever circuit we're doing goes into here. We make sure that into 9, yeah. Into 9, let me just double check the, yeah. Number 10 and 9 are an AND gate into 8. So, this works, but this AND gate isn't working. Did I power the AND gate on correctly? I believe so. The AND gate ground is number 7 and 5 volts is number 14, so that is on. Let's see. That's going to ground. Did I do this the correct direction? I did. Yeah, I don't know why that is not working. Why is this not turning on? I assume. Whoop. Oh. Because I did it on the wrong side of the LED, so it was tied low. That's why. But as soon as I pulled it out, the way that the circuit is in the AND gate, I think it ended up being tied high. There we go. All right, so there's that. And then if I instead do our output from number 3 here. Okay, so that AND gate is working properly, and so I've got a halt set up correctly. So now let's see the rest of this circuit. All right, yeah, that's something. So OR is coming from either one of these, and this is just going to determine which one is supposed to be out. So the OR is going in from 3 to 9. Let's just stick with this because It's there. Oh, whoa, whoa, whoa. Sorry. Number 3 of the OR gate. Actually, the one on the OR gate doesn't actually matter, but 1, 2, 3. Yeah, 3, 2. Number 9. Yep. Okay. This is where we're gonna start getting into that weird moving around circuits. All right. Let's just pop this over down here for the moment. Let's see if this is going to be long enough. I don't know that it is. Don't know that it is. Is that bend correct? Let's see. That'll work. That'll work. Yes. Yes. Excellent. Oh, that's that always sounds fun. Getting to be that time of the year that it's got to get out, huh? There we go. Yeah, that'll work. Yeah, our in our apartment complex, our ACs are like tied into the our ACs are just permanently in the frickin' walls, so they leak heat. I have to like tape it up. I like tape saran wrap around it to just stop the wind from coming in and out of it. It's not my favorite. All right, so that'll work. So that OR gate. All right, I'm just being as paranoid as possible here. So this OR gate. If I do this. No. What? All right. Number 3 is the output there. This is my OR gates, right? Ah! I put this chip in backwards. Oopsies. Let's try that again. Yes, indeed. Are you in the Northeast as well? All right, so that does work. All right, so the OR gate works. You know, good to check that. I've made a mistake every time now, so I'm glad I checked that. Oh, you're in Pennsylvania. Oh yeah, so you're pretty close by. Speaking in terms of the United States. Yeah, we're expecting snow in New England too. All right, let's see. So we've got the OR gate. So now we need to connect up this OR gate to these ANDs. And these ANDs are basically saying if the switching circuit and the output of this is set together versus the switching circuit and the output of this, then it will come over. So the switching circuit. So let's tie the outputs to the OR gate first. So number 3 of the AND gate goes to number 1 of the circuit there. Let's see. Gray has gray. Number 3 to number 1. Oh, that's number 4. There we go. You know what? Number 3 to number 2. So close. All right. I think purple is the correct size then. Number 3 to number 1. There we go. And then number 6 to number 2. 1, 2, 3, 4, 5. I think that's my yellow. I think this is actually my last yellow. Yeah, I'm in New England. You're originally from the Boston area. Very cool. My sister went to college in Boston. Guess which one? There's only 50 fucking colleges in Boston. Number 6 to number 2. This is actually too small. Let's see. What do we do? The green for this. Yes, I believe it is green. Gotta get my tweezer pliers in here. All right, there we go. Roger is from Massachusetts as well. You're probably your hometown is probably pretty close by where he is. Well, within a couple hours anyway. Number 2 to number 6. Number 6. Yeah, number 6 to number 2. Okay. And come on. Number 6 to number 2. Boop. That's exactly how I want that right there. Nice T-junction. That's totally how that's supposed to work, right? Oh yeah. Yeah, one of my friends is from the Cape itself. She quite enjoys it, and hates it because she grew up there. But very nice area anyway. All right, I don't like that how this is going over that. I'm gonna change this slightly. I'm gonna just run this parallel. Run that parallel to that, and it can go into 2. All right, there we go. Yeah, that'll work. Okay, that's much cleaner. I like that. Okay, so we've got our AND outputs. So now let's set up our AND inputs. So we want to say number 5 is going to be our output from number 3 of our manual clock. So number 3 in our manual clock goes all the way to number 5. Right here. Let's see. This is the first of like the reds that I'm using. That is, it is not long enough. All right, let's see. What about the orange? Number 5 to number 3. Oh, it is so close. All right, let's clip that just a tiny bit. Osterville. I am not familiar with Osterville. I'm actually not super familiar with the Cape in general. I've been there for like barbershop conventions. There's a barbershop convention that is occasionally on the Cape. But I am actually not super familiar with the area. Village type towns though. That is a don't use my hands to strip the damn thing. Hold on. There we go. What do you find appealing about village type towns in Pennsylvania? Just the close-knit community sort of thing? Let's trim this a tiny bit. There we go. And then there we go. Close enough. Yeah, there we go. And number 5. Number 5 all the way back to number 3. Oh, perfect. Excellent. So, and then I need the NOT output of the inverted output of number 3 from this circuit. So this circuit into an inverter and then into my AND gate. Let's see. Just quiet country life with fiber internet. 800 people, no police, no actual fire station, no shopping malls, no factories. You know what? All right, that's fair. I can see the appeal there. I'm really running out of room here. I'm gonna have to move this down again. All right. Number 3 is our output. It's going into an inverter. It does not matter which inverter, because I'm not using any of them at all. So that's going into number 3, because I feel like it's supposed to go into 1 and 2, but I don't care. Inverter, and then output is coming out from number 4. and going into number 4, actually. Huh. Number 4. Yeah. Oh, that ended up being perfect. Excellent. I'll take that there. Slightly askew, but you know, whatever. Okay. So in theory, one of these should work. I mean, that's not quite right, but let's see. Hold on. The other one. Nope. Okay, something's wrong. Let's see. This is number 3, inverting here, and then into. Oh, actually. Yeah, so the output of this one is always going to be low, so that's fine. So it's only this circuit that I need to worry about. So we've got going into number 4 and number 5. We've got the output of our button here. And then that goes into here, which then gets ORed and then goes out. So that's all right. But why is the LED on and just going higher? Wait a minute. It just gets brighter. Versus here it doesn't change at all, so I think I'm short-circuiting it. There's one gas station in town that is also a liquor store, hot food shop, and general store, and it is the only gas station in town. That is definitely a small town. I will not deny that. I do like my shopping malls. I don't think that I could do that life personally. Well, just to double check, my halt, if I tie this high, yeah. Wait a minute. Oh! Just gonna pull that out. Hold on a minute. Yeah, I keep this tied low. I keep this tied low and it works. If I tie it high, nothing happens. So I think I'm short-circuiting that somewhere. But how? Where? Why? Who? What? Just out of curiosity. Yeah. Oh yeah, that's a problem. So... number 2 is correct there. So number 3, the output of number 3, I'm looking here, the output of number 3 is going to here. Alright, what did I do? I'm so close to actually finishing this. So take the output of this, take the output of number 3 here, which is this is in number 4, yeah, and then also tied over to number 2, yeah, and then the middle is tied ground, yeah. Wait a minute, am I missing a capacitor in here? No, that's just on number 5, okay. So, number 3 goes to the inverter, port number 3, and then 2, port number 4 here, which is half of the AND gate. This is the other half of the AND gate. Alright, hold on a second. Yeah, no, something's very wrong here. it gets brighter, but that's not what I'm looking for. And then again, the halt works. So if the halt works, it's this output that's wrong. 1, 2, and 3 output. Did I burn this out? Oh no. Oh no. No, wait, hold on. Hold on a second. No, I definitely... Ah! I'm so sorry. Yeah, I'm gonna pull those out for a sec. Where are we going from those? Where did those go? All right. Let's see. Yeah, this ore is high. Yeah, that ore is tied high. That's not good. Or is it my inverter is tied high? Or is it that I'm short-circuiting this completely differently? What the shit? How are you high at all? Alright. I've got the output of an AND gate that is just permanently on. Yeah, that AND output is just totally high. 100% completely high. Is it because it is tied high? So what if I tie both of those low? Let's try that. If I tie both of these low, because like part of it was working. Hold on. So let's put this back in. This is my... Oh, nope, wrong one. This is my input to my AND gate. Comes out of an OR gate. That OR gate is currently low, right? I believe that OR gate is currently low. Oh, I got my S backwards. That's why it's not fitting properly. There we go. Hold on. Just get that slightly twisted around. Hold on. I know. Yes, I'm still listening. Hold on. Gotta keep that music flowing. My output of my OR gate is now should be low. The output of my OR gate is low. The output of my OR gate is low, assuming that those are also both low. And I will tie them low to make sure that they are low. I should have my this is where the other kit comes in handy for all of the extra little cables to just tie things up and down. Alright, so let's see. Hey, OR gate, you're low. The OR gate is low. Low. The OR gate is low. So there's no input going to that OR gate. That OR gate should be a 0. This purple ties the inverter here, the inverter for my halting to here. So there it is currently high because it is not tied to ground. Yes, so I tie it to ground and it goes low. So I have 2 low inputs. That is correct. So I think I just need to hook up the rest of the circuit. I think that the AND gate is just getting tied high. All right. So all right. Yeah. All right. So OR gate number 2 going to number 6. Yep. 3 going to number 9. I'm sorry, 2 to 6. Number 1 to number 3. Yes. Yeah. That's correct. All right. Then, so the other AND gate, I will tie low. Though it doesn't have any output going to it. Yeah, this is the output of the other AND gate. Yeah. Okay. So the output. So now this one AND gate is totally low. The other AND gate is low. And it's not doing anything. Which means I don't have my inputs going correctly here. Nope, that's correct. What if I take both of these out? It does nothing. Huh. Well, I've completely baffled myself. Alright, so not. So let's see what's high and what's low here. Number 3, the output of this. Let's take a look at that. Let's take a look at the output of number 3. Yeah. And we'll find out which way this is going. The output of number 3. Ground. Okay. So. Troubleshoot. Alright. Alright. So let's see. So this is currently on. If I flip it the other way, the output goes to 0. Okay. So right now the output is 0. So the output of number 3 is 0. That is going into number 3, correct? Yes. 3 is 0. 3 goes to here and then flips to high. So high. And then high, and then output of... Oh! I've misaligned something. No, I haven't. No, that's correct. Yep, the output here is high. So the output here should be high. Oh, well, it should be low at the moment, and then if I hit the button, it should go high. Let me try and see if I can do this in the most jank way possible. Yep. Oh yeah, that works. Look, yeah, so it works. So then the output of that is going to that OR gate. So that OR gate should be going high. Oh! I took out my halting. One. It's still a problem. Okay. So the halt is still a problem. Why? Why is halting a problem? Alright, hold on a second. What if I do this? So what am I doing? What is on this line that I'm fucking up here? Alright. Hold on a second. Unplug this for a moment. So the output of this one here versus ground. So the output of this one here versus ground. Oops. The output of here versus ground is 2.9 volts. Why is it 2.9 volts? So it goes up to 5, or it goes to 2.9. Why? Because I didn't tie the clock to ground? No. The clock gets tied to ground. The output of this OR gets tied to ground through the LED. Or the output of this. The output of this AND. Yeah, so it's giving me it's giving me 3 volts out instead of 0 out. Why is it giving me 3 volts out? Why is it giving me 3 volts out? Yeah, this OR gate does not make sense to me. Why is it giving me 3 volts out? I need to fucking tie it low? No, that doesn't make any sense. It is tied low here. Hold on a second. I just want to take a look at the picture again, because the picture might give me some insight as well. Nope, it just, yeah, it's exactly the same way I have it. So that OR is just giving me the wrong output. Huh. But why? But why? Why is it giving me this? Okay. So, is it the output of the OR, or is it the output of this AND for some reason? Hold on a minute. Let's decipher that. Oh. I really gotta stop hitting that. Alright, let's try that. Let's just double check that this AND itself. Oops. Yeah, this input is giving me nothing. But if I touch it over here, it's giving me 3 volts. Why is it giving me 3 volts out? This is giving me 3 volts. It's not like that cable is giving me anything, but so neither of these are working. All right, so hold on a second. What if I do an output of another one? This one. Yeah, you know what? I think I burned this out. It's giving me 2 volts here for no reason. Well, it's cut down to 0.9, 0.8 volts. But like it should be giving me 0. This is giving me 5 volts. Oh, shit. That one there. Yeah, I think that I've totally fried this. Because if I get the output of this AND, it gives me nothing. No, hold on. Or it gives me, oh, it gives me 5 volts potential. Wait, why does the output of that AND give me 5 volts? Because I need to tie the AND low, that's why. I get the output of this AND. This gives me 0. Yeah, if I get the output of this AND, it gets me 0. Because it is tied low. So it's this OR gate that's the problem. So the output of this OR gate gives me too much. What if yeah, and it's just all fucking over the place. Just again, just to confirm. Damn it, I didn't want to pull those out of the entire thing, but okay. Just to confirm, with no inputs on this OR gate, it gives me 5 volts. What about with low inputs on that OR gate? With low inputs on that OR gate, it gives me 0.57 volts. So, you know, I think I'm going to try using a different OR gate on this chip. I'm going to try using a different OR gate on this chip and see. Actually, no, wait. So if it is tied low here, hold on. If it is tied low, it gives me 0.59 volts. Okay, so hold on. So that means that one of these other two is not giving me the correct input. So you are going to here. You are going to here. So wait a minute. Did I just goozle myself again? Did I goozle myself again? Should I just finish assembling the fucking circuit instead of trying to troubleshoot every step of the way and get goozled by fucking AND gates that pull high? Alright, these pull low. Alright, when these are low, these AND gates are low, the output of those should... That one is low. Alright, hold on a moment. And that gives me low. I need to just finish fucking assembling this circuit. Hold on. Hold on. I feel so dumb because I keep doing this to myself. Alright. Output of 3. Output of 3 going to input of 9. And you go here. That's what happens when I'm tired and I can't think all the ways. Alright. Can't believe that I did this. Oh look, it's down. It's low. Okay. But now if I put my halt in here into an inverter, and I should have one more purple around. Where's my purple? Hold on a sec. Where's it? Oh, here it is. Go on. Get in. They updated BlueStacks and now it's broken? What happened? Alright, there's my halt. Do not turn on, please. I need to finish assembling the circuit. If I don't, this AND pulls high. Gosh fucking damn it. Troubleshooting this shit. Cause sorry about the camera. Troubleshooting this shit because I can't fucking remember that the ANDs get pulled high. AND gets pulled high. Virtualization is not working. Ask me to turn off the UEFI? Oh dear. That's not fun. I have not used BlueStacks. It's been a while since I have honestly even heard the name. I think I've loaded it for some of the kids at my school system, but all right. Turn this other and into the correct one. All right, so this and should be the output of number 3 and the output of the blinky one. This and is the output of number 3 and the output of the blinky one. All right, I do know something. This and goes here. Slightly too long. There we go. Yeah, there we go. Strip. There we go. All right. Now clippity clip, please. Clippity clip. All right. It does indeed look like some stale bread. How's it going? If you use Android, you can sign into your account with it on PC, send and receive. Yes. That is vaguely familiar. Oh, I knocked into my microphone again. Things are all too close. All right, number 3. We're gonna take number 3 from here, sneak it in there. Bring it over to number 2 here. And then let's just kind of poke that in there. Stay. Get. There we go. Oh, I should probably pop it into this one because I feel like it. There are a couple that I actually want to do that with. Yeah. All right. It's still circuits and one slice is burnt. No, I just was dumb. I was just dumb. It's not burnt. I just forgot how AND gates got tied high instead of low, and it's fine. Just troubleshot shit for 10 minutes until I realized that I'm an idiot. It's fine. Really, what I'm saying is it's fine. Okay. Yeah, that one's gonna get hidden in there. Oh. Really gotta get that halt out of the way. Alright, so we've got 3 tied into 2. So let's tie 1 into the output of 3 here. This is not long enough. I need a yellow. Output of 1. Is that right? Output of 1? Yeah. Oh, it's so close. All right, hold on a second. Strip. Oh, that didn't work. Wrong with. Oh. Strip. There we go. Strip. And then a big ol' clippity clip. And then we turn and hope that that's deep enough. Oops, it was a little bit not perfect there. Okay, get that in there and get this one over here, right there. Okay. Yeah, just get all those along. All right. So our clock output is good there. And we switch this circuit. Hey! All right. Our clock output works. Ah! And it shouldn't do anything there. Yeah. Let me flip it back over here. And boop, 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 boop. Oh my goodness. Excellent. Both things work the way they're supposed to. All three things work the way they're supposed to. I did it! Part 1 complete. Alright, now I gotta make sure that I do these right. This is in pin 2. I'm gonna clip these down now that I'm confident that they are in the right spots. I know, Crazy Gamer. You did not believe I could do it. But let me tell you, I got there. Barely by the skin of my teeth, by actually finishing assembling the fucking circuit. I got there. Alright, that's a resistor in there. It's a slightly up there, but that's fine. And then I did the thing I set out to do, and I did it in a reasonable amount of time, which is actually the fact that I'm not up until 11 o'clock tonight is really the fact that I'm not up until past 11 doing this is the real win here. All right, there we go. Let's make sure that still works. Yeah. I do have to figure out what the yeah, it's as fast as that's gonna go. Oh. And then if I do it that way, it slows it down. Yeah, it's not a huge difference, but I'm gonna have to figure out which of these components I'm going to have to 11 yeah. Which of these components I'm going to have to switch out. I think it's the capacitor, but it might be one or both of these resistors to make this actually blink in a reasonable amount of time. 11 is my pumpkin time. It's not quite, but I am up past 11 too much as it is. So it's nice when things are not. If I take that halt out of curiosity. Okay, yeah, no, so I need to keep that halt tied. I need to keep that halt tied low. Oh, that's brutal. Need to keep that halt tied low. Oh, or is it tied high? Oh, no, I just plugged it into the wrong one. Alright. Cool. I'm just still thrilled that this is working. I need to keep this halt tied high, so that I won't, I have a shorter yellow. Let me do that. So that the circuit will continue to work. So I can always pull it in an emergency. So that's, that is an advantage of the halt mechanism. Though it's not, at the moment it's not a big deal, but eventually the computer will be able to automatically call this halt. Which is really why this is here, because eventually it won't be me calling the halt, it will be the computer saying, okay, I'm done, and pulling this. So, pulling this. Let's get the last two the last two pieces of the circuit into nice flat shape, and then I think I'm gonna call it a night. This resistor ties this circuit, ties this LED low. I don't think that went in very nicely. Hold on. Trying not to hit the camera with this again. Yeah, that did not look great at all. Okay. There we go. That felt much nicer. All right, and then this LED. Just try and bend the anode so that I know which one is the anode. Because otherwise I'm gonna forget which is the anode and which is the cathode. So there we go. Go in. All right. Oh. Like, look at this. Look at this. It's all nice and flat. Now hook it up to the DAC. What's the DAQ? What's the DAQ? It literally says data acquisition, sampling signals. This is I'm missing a joke here that I really actually should do this. Data acquisition is the process of sampling signals that measure real-world physical conditions and converting the resulting samples into digital numeric values that can be manipulated by a computer. A serial interface for PC. Ah! Oh, yes. Okay, sure. So actually, so again, this whole circuit, the idea is... no. The idea behind this circuit is to eventually build an entire breadboard CPU. Can I do anything interesting if I hook it up to an Arduino? I mean, this takes 2 inputs essentially and creates, well, 3 if you count the potentiometer, but 2 inputs and then gives a single output. So right now, this is the first part. This is the first part. So the first part is just getting the clock. And now I have the clock. And now I can move on to the rest of the thing. So actually, so this is a good point at which to start to wrap up and give a bit of a spiel, because eventually the idea is that I will not be hooking it up to an Arduino, but instead making it an Arduino itself, essentially. So the entire breadboard computer, this is literally the top left clock circuit. This is literally it. The rest of this is the rest of the kits. I don't have the other kits with me. I should have brought them down. Let me go run and find out what the next one is for next week. Hold on. Because that's what I'm going to do next week. Alright, so this is a really, really long way around building a timer. Yes, but the idea is that it is all going to be well, my favorite part is the I built a button. Literally, I have a button and I'm using it to build a button. So here's the thing. This is next week's. The registers in the ALU for it. So next week is going to be building the registers and So I can do addition and subtraction and stuff, which I believe is this section here of the computer. So the clock will be running that, and I can set the initial inputs, and then using the clock, manipulate them there. I believe I might also. I don't think I'm doing this. I believe this is the program counter. Yeah, this is the RAM and the program counter over here. Boop. So the RAM and the program counter, that is weak. I say weak, it's kit 3. We'll see if I actually get to do the entirety of each kit every week. I don't necessarily know that I am. And then the final one, the final kit, is the output and control logic. And so that's actually the stuff down at the bottom. And that has the little 7-segment display. And these are all of the control flags and everything, or like the output flags. And then there's an EEPROM that you can program as well to use as a ROM for what you want to actually do with it. Now, I think that what I want to do past the 3 kits is, with the memory management section of it specifically, the RAM, I would love to have a separate circuit on here as well that acts as a stack. I would love to have some dedicated RAM, or use some of these memory modules if I need to. But it'd be nice to have an additional board that has some RAM that is specifically marked as the stack. And so being able to push and pop stuff off of there, that's one of the things that I find the most useful when doing assembly programming, and especially with a CPU where it's very single process oriented. That seems like not an oversight to me, but it seems like something that could really use. And eventually, I don't think that it's actually really something that's going to be super possible. It'd be nice to get these to upgrade to 16-bit, but I think it'd be really neat to Ben Eater, who again, Eater.net, Ben Eater, who built this design and has built this whole circuit on YouTube. He also did his first video that I watched was actually him building a breadboard VGA graphics card. And I would absolutely love to be able to try and get some sort of VGA output for this in the worst possible way, but some VGA output for this, and possibly start trying to figure out some sort of keyboard input for it. That would be craziness if I could actually get that running, but we'll see. Right now, I want to just build the CPU as is, and then we'll see about adding on. Now, obviously, I'm not doing that tonight, so check in next week, 7:30 Eastern Standard Time. The East Coast is going back to GMT -5, so come check that out. I'm also going to be playing Crusader Kings on Sunday, per usual, which is much more what my usual deal is. So, come check that out if you are interested in strategy. Otherwise, make sure that you follow and hit the notification button so that you actually get notifications. because that would be neat, and you can make sure that you see this next week. I'm so thrilled that I built a working circuit with a variable speed, though again I'm gonna figure out what needs to be changed around to make this go even faster. Variable speed and this switcher. Thank you so much for joining me. Hopefully I'll see you next week. Have a great night.